operations center or in the SOC, we need to quickly detect abnormal traffic. That's a given. Unfortunately, many different traditional detection methods take a lot of computational overhead, which will make it hard to meet the real-time requirement that we need nowadays, especially to detect, different sophisticated attacks. Now, there are many different studies and solutions that provide a distributed network traffic anomaly detection algorithm based on a concept called the sliding window, which is basically through this, sliding time or sliding time window, traffic abnormality detection will be limited to only the specific amount of time, so the scope is a lot smaller. Now, this significantly reduced the amount of data analysis to improve the speed of abnormality detection and to be able to scale, be able to actually reduce the need of all that overhead of computational analysis and basically take advantage of this sliding time window for that specific limited scope of time. Something bad or unpleasant will actually happen. And this is according to the Merriam-Webster's dictionary. And the Federal Financial Institutions Examination Council, or FFIEC, has developed the cybersecurity assessment tool to be able to help financial institutions identify the risk. And this is actually something that not only financial institutions leverage, if not other organizations, both in the public and in the private sector. And the link that I include here has several resources and information about this tool. Also, the International Organization for Standardization, or ISO, they actually have developed standards that are very heavily focused on risk and specifically on risk-based planning. An example of that is the 27001, and there's also another standard by the ISO in combination with the IEC that is the Information Technology Security Techniques and Information Security Risk Management, and is more focused on cybersecurity risk assessment, and the number is 27005. Now, there are also standards that score the overall risk of a given vulnerability, and the primary standard to score vulnerabilities is the Common Vulnerability Scoring System, or CVSS. And CVSS actually has been developed by the first organization. And here I'm actually showing their page, and where they actually have, the standard specification document, and the current standard or the current version of the standard or the Common Vulnerability Scoring System is version 3.0 at the time of recording. So as you see actually here, they actually have several, different resources as well as a really good documentation. So let's go over some very briefly, right? So CVSS actually have three different metrics groups: the base, the temporal, and the environmental scores, and each of those consist on a set of specific metrics, right? So the base group actually has explorability metrics as well as impact metric, and the explorability metrics include things like the attack vector, the complexity of the attack, whether you actually require privileges for an attacker to be able to exploit a given vulnerability, whether that vulnerability also requires user interaction, and if in the impact metrics is if the vulnerability actually impacts confidentiality, integrity, or availability, right? One thing that is new in CVSS version 3 is the scope metric, part of the base score. Most vendors and folks that actually report or disclose vulnerabilities, they actually use the base score to be able to actually calculate the impact, overall risk of a vulnerability, right? So that's what most customers also actually use as a common determination, whether the vulnerability it's actually more severe than the other. Now there's also the temporal score that actually goes into three different sub metrics, right? So the exploit code maturity, the remediation level, and the report confidence. Also, this is used by vendors whenever they disclose vulnerabilities, right? So Cisco, and specifically, actually, I'm part of the PSIRT team, does disclose vulnerabilities, to the public. We use the base and the temporal scores every time that we publish a vulnerability. We also use security impact rating, but I will mention that in a few minutes, in this lesson. Now, there's also the environmental metrics group, and that group is used by the consumers of the vulnerabilities, right? So that environmental metrics depends on the, the word environment on your environment, right? So let's say you actually have a vulnerability that may have a different implication to systems that are specific to your environment. This is the type of, metrics that you will use to overall score the vulnerability and the impact to your organization, right? So the metrics group include the modified-based metrics, confidentiality requirements, integrity or availability requirements as well. And I briefly mentioned that Cisco uses the security impact rating, right? So, or what we call CSIRT. And the purpose of that, scoring, is to make it easier for the person that is consuming the vulnerabilities to be able to assess the risk, right? And we classify it on high, critical, medium, and low. And it's basically fairly similar to the qualitative severity rating scale that was introduced in CVSS version 3.0, right? And I'm actually sharing here first website and documentation for CVSS version 3. And as you can actually see, there's a direct mapping of the qualitative, severity. In our case, in Cisco, is the security impact rating and the CVSS score, right? So if you see here, critical equals to 9.0 or to 10.0. And one thing that I actually failed to mention is that CVSS metrics, specifically the scores, vary from 0 to 10, 10 being the more severe, right? So as you see here, critical, it's 9 to 10, high 7 to 8.9, medium 4.0 to 6.9, low is from 0.1 to 3.9, and also none, of course, is 0. So that means that there's no impact, or perhaps it's actually not a vulnerability itself, right? So again, this is actually for your reference. Probably the test will not actually go into this detail, but I wanted to provide you with some references about CVSS. There are other standards that actually measure the score or the risk of other cybersecurity, items, right? So specifically, some developed by MITRE, right? So an example of it is actually the Common Weakness Scoring System, or CWSS, which is actually a methodology for scoring software weaknesses, right? And CWSS is part of the Common Weakness Enumerator, or CWE. And it's, documented very well at MITRE's website, and I'm providing the link in the screen. And another one is the Common Misuse Scoring System, which is a standardized way to measure software feature misuse. And, there's also, a lot of documentation around this at NIST website, and I'm including the link in this screen. And lastly, we actually have the Common Configuration Scoring System, or CCSS, and actually it's a metrics for software security configuration vulnerabilities, right? So if you actually have configuration malpractices, and this actually documents this very well. And again, I'm providing the link to the NIST publication in this screen as well. Exploitable weakness in a system or its design. Actually, vulnerabilities can be found in protocols, operating systems, applications, hardware, and also systems designs, as I mentioned before. There are thousands of vulnerabilities abound, and there are more discovered every single day. You will learn many examples of vulnerability classifications in Lesson 12. However, the following are a few examples. The first one is actually SQL injection, which actually targets databases, right? So it's the ability for you to be able to inject SQL statements to do, many different things like drop tables in a database or corrupt records or steal data. So we will cover, some of these, definitely in lesson 12 in more detail. The second one is cross-site scripting. It's a web-based vulnerability. And then we also have buffer overflows, privilege escalation vulnerabilities, cryptographic vulnerabilities, and many, many more. So again, in lesson 12, we actually go and deep dive into some of those. Vendors, security researchers, and vulnerability coordination centers typically assign vulnerabilities that are disclosed to the public with an identifier. And this identifier is known as the Common Vulnerability and Exposure, or CVE, right? And CVE is the industry-wide standard, and it's actually sponsored by the US CERT and the Office of Cybersecurity and Communications of the US Department of Homeland Security, and also coordinated with MITRE, right? MITRE actually copyrighted the CVE list for the benefit of the community in order to ensure that it remains free and an open standard. So also MITRE, does this to legally protect the ongoing use of CVE and any resulting content by government, vendors, or any other users, right? So MITRE actually maintains the list of CVEs and its public website, and it manages the CVE compatibility program. There's also the National Vulnerability Database, which is also maintained by NIST, right? And that's what I'm actually showing here. Now, MITRE actually oversees the CVE naming authorities, or CNAs, and provides impartial technical guidance to the actual editorial board, to the CVE editorial board, and it does that through the process to ensure that CVEs serve the public interest. Now, the goal of CVE is to make it easier and to share data across tools, vulnerability repositories, and also security services. You can actually get more information about CVE at cve.mitre.org, and I'm sharing the link in here. Now, let's go over what are actually threats, right? So threats is a potential danger to an asset. So if a vulnerability exists, but it doesn't have, or it hasn't been exploited yet, or more importantly, it's not yet publicly known, the threat is actually latent. So it is what we call that it hasn't been realized. If someone is actually actively launching an attack against your system and successfully, access something or compromises the security of that asset, then that's whenever we consider the threat to be realized. The entity that takes advantage of the vulnerability is known as the malicious actor or threat actor. So there are many definitions, out there, and some folks actually just call them hackers. Other ones actually prefer not to use the word hacker because anybody can actually be a hacker and modify systems not only for a malicious intent. So the industry is actually moving into calling these either attackers, malicious actors, or threat actors, right? So basically all mean the same. And the path actually used by this actor to perform the attack is actually known as a threat agent or threat vector. Now, a countermeasure is a safeguard that somehow mitigates the potential risk, right? So it does this by either reducing or eliminating the vulnerability, or at least reducing the likelihood of the threat agent to actually exploit the risk. So, for example, you may have an unpatched machine in your network that making it, highly vulnerable. So if that machine is actually unplugged from the network, it actually ceases to have any interaction with, exchanging data with any other device. So you may actually have successfully mitigated all those vulnerabilities. However, you likely render that machine no longer an asset. And, of course, it is safer, but, it kind of defeats the purpose, right? You took out a machine that, had some purpose within your environment, right? So that's the type of, things that you actually have to consider whenever you apply countermeasures or mitigations, right? So what is actually the benefit of that? At the end of the day, what you actually want to do is patch vulnerabilities, right? So, remediate vulnerabilities, not just apply workarounds or mitigations, right? And in some cases, the mitigations, like I just explained, they actually don't make a lot of sense in your environment, and in some cases actually are perfectly fine to be deployed, and somewhat in a somewhat permanent way, and I'm really adamant of actually saying permanent way because, again, I actually urge everybody to actually do a correct patch management and actually upgrade the systems. Let's go over what is an exploit. An exploit is a software or a sequence of commands that actually take advantage of a vulnerability in order to cause harm to a system or to a network. There are several methods of classifying exploits. However, the most common two categories are remote exploits and local exploits. A remote exploit can actually be launched over the network and carries out the attack without any prior access to the vulnerable device or software. Now, the local exploit, which is actually different in this case, requires the attacker or the threat actors to have prior access to the vulnerable system. Right? Exploits are commonly categorized and named by the type of vulnerabilities that they actually exploit. Right? There's also the concept of exploit kits. Right? So an exploit kit is actually a compilation of exploits that are often designed to be served from web servers, right? The main purpose is actually to identify software vulnerabilities in client machines that are connecting to those web servers, and then exploiting such vulnerabilities to upload and execute malicious code or malware into the client, right? So malicious code is also referred to as malware. The following are a few examples of known exploit kits, and there are many more there. This is just a few examples of them. The first one is actually Angular, and actually Cisco Talos have covered it and explained numerous exploit kits in detail, including Angular. And I'm including a few links in here for your reference from a Talos blog that you can actually get more information about this exploit kit, right? So again, we have Angular, we have MPAC, Fiesta, Phoenix, Black Hole, CrimePack, Rig, and the list goes on and on, right? So again, the main purpose of these exploit kits is actually to identify software vulnerabilities in client machines and then exploiting those vulnerabilities to upload and execute malware. Stands for authentication, authorization, and accounting. Authentication is the process of providing the identity of a subject or a user. Once a subject has identified itself, the enforcer has to validate the identity, that is, to be sure that the subject or the user is the one that he claims to be. This is done by requesting a subject or a user to provide something which is unique to the requester. There are several authentication methods out there. The first one is authentication by knowledge, and that's something that the user knows, something like a password or a PIN. The next one is authentication by ownership, which is something that the user owns. An example of that is a smart card or a badge or a token. And then authentication by characteristics, and that's actually something that the user is or is not, right? So that means things like biometric authentication, like fingerprinting, hand geometry, the keystroke or the dynamic keystroke of the user, and other methodologies. Now, authorization is the process of granting access to objects or a resource of to a specific subject, and this typically happens after the subject has completed the authentication process. An authorization policy should implement two different concepts: implicit deny, and that means that if no rule is specified for the transaction subject or for an object, the authorization policy should deny the transaction. And then the second one is a need-to-know basis. So the need-to-know is where a subject should be granted access to an object only if the access is needed to carry out the job of that subject or that user. Now, accounting is the process of auditing and monitoring what a user does once a specific resource is accessed. This process is sometimes overlooked. However, as a security professional, it is important to be aware and to advocate that accounting is implemented due to the great help that it provides during the detection and investigation of cybersecurity breaches. When accounting is implemented, an audit trail is created and stored detailing when the user has accessed the resource what the user did whenever, was actually accessing that resource, and when the user stopped using that resource. Now, given the potential of sensitive information included in audit logs, special care should be taken in protecting them from unauthorized access.